Hello, everyone. Good morning, good afternoon, and good evening from wherever you're joining us from. My name is Dalia, and I'm part of the developer marketing team here at Kong. I'm very happy to welcome you today to our user call. The theme for today is the Federated Configuration Management at Scale with decK, and we have Michael Heap with us today. I will let him introduce himself. Please use the Q&A function on the bottom when you want to ask your questions. When Michael is done with his presentation, he will answer all of them. Please use it instead of the chat so we can keep better track of what has been asked and answered. And if you have any technical issues or any comments, please use the chat function. I will also include a link to our YouTube channel where you're going to be able to find the recording afterwards. We will also send a follow-up email to all of the people who have registered and everyone who attended and also who didn't attend with some resources with the recording in the next few hours. So you can expect also to get an email with the recording in your mailboxes. Yeah, and I think that's it. Michael, please take it away from here.
Thank you very much. Good morning, afternoon, and evening, everyone. Thank you for coming to learn about Federated Configuration Management at Scale with decK. If you've seen me on these calls before, you'll know that sometimes there are slides, but for the most part, I don't want to bore you with slides. So this is going to be a very hands-on, demo-driven session. We'll start with the basics. Like, what is decK? decK is a command line tool that Kong provide. decK is short for Declarative Management for Kong. That's why it's got the capital K. And decK allows you to sync your configuration. If you've used decK, this is probably how you use it. You run decK gateway sync with the YAML file, and it configures your services, routes, plugins, everything you need to be to successfully proxy traffic with Kong gateway. But it can do so much more than that. For example, did you know that you can lint your configuration? So you can say things like, make sure that all routes only listen on HTTPS, or that all services have a timeout of 5 seconds or less. Did you know that you can manipulate your configuration? So instead of just linting and failing the build, if the rules aren't followed, you can force specific values into the configuration without actually touching the source file. This is useful if your application teams are configuring Kong Gateway, and then you as a platform team need to layer additional policy and governance on top. And then finally, decK can actually generate your configuration. Things like decK file OpenAPI to Kong allow you to go from an OpenAPI file to the Kong declarative format, and also from the Kong declarative format to things like Kubernetes HTTP routes. So there's actually quite a lot to decK. I think most people really stick in box number one. We just use it to sync configuration, but it can do so much more. Like I said, this is going to be very demo heavy. So I'm going to flick over to VS Code and just show you the basics of how decK works, plus a really cool new feature that you may not know about. Actually, before I do that, I want to show you that this isn't pre-recorded. Like, I have a control plane, it's empty, and there is nothing here at the start. I will also need to set some environment variables. Yeah, I will do that. Oh, I need to set that first. So I need to set my authentication credentials and also export decK connect. This is how you know it's live, because I'm forgetting the name of the environment variables. So what I'm doing is setting an authentication token for decK and telling it which control plane to sync to. You can pass these as environment variables. You can put it in a configuration file, or you can pass it as command line flags. So for example, connect token, if I can type, um, these flags are equivalent to the environment variables that I just set. So maybe that's the first thing you've learned today. You can actually configure environment variables that decK will read and use for all of the commands. I've got this sample decK file. It just defines 3 services. The example that I'm using is based on Kong Airways, which is a fictional airline that I use in all of my demos. And it has 3 services: a flight service, a booking service, and the customer service. And what I can do is decK gateway sync, change the right directory, decK gateway sync full, and this will create all of those services in Connect, which is our cloud hosted control plane. If I go into services and take a look, we can see that they've appeared immediately. And if I run decK once again, nothing is created, nothing has changed. Those services already exist. You might be thinking, well, yeah, I know how to do this. Like decK gateway sync, I use it all the time. What happens if you want to add a 4th service? So for example, this destination service, you go ahead and you sync the destination service. Wait, what just happened? Like, why is it deleting customers, flights, bookings? Like, yes, it created my destination service, but everything else is gone. That's because decK gateway sync expects to receive a complete configuration every time it's run. So if anything is removed from the file, it gets deleted on the control plane. To work around this, what you can do is pass multiple files. So decK gateway sync will accept multiple command line arguments. So I'm saying here, just take all of the files, merge them into one, and sync them together. And now all 4 services will appear in the control plane. But if you're just experimenting and you're trying to build a new service or a new route or a new plugin or something like that, maybe you don't want to sync the entire file every time. Maybe the file is more than 3 services. Maybe it's 1,000 services and it takes a little bit longer to run decK. So if I just reset it back to the 3 services and we delete destinations, what I want to show you is the decK gateway apply command. And what decK gateway apply does is it just layers on the new content. So if I apply new .yaml, you can see that it created a service, but nothing was updated or deleted. And if I go back to the control plane and refresh, we've still got all 4. So what decK gateway apply does is it allows you to incrementally build up your configuration file by file, whether you're copying and pasting from documentation or from other examples that you have. And then once you're done, you can just run decK gateway dump and you will get the entire configuration to use with decK gateway sync. decK gateway apply is something that was added recently and I use it every day. It's one of my favorite commands to just incrementally build your configuration as you're exploring before you use decK gateway sync with a Git repo and a CI/CD system to continuously apply that to production. I said it was going to be the basics. Just decK gateway sync, decK gateway apply. like I said, it makes sense when there's one service or two services or even 10 or 100, but when you get into the thousands or if you have millions of consumers, this takes time to sync because it's got to fetch the current state and calculate the differences. I've seen this take more than 5 minutes, more than 10 minutes when you've got millions of consumers. Which takes us on to point two, which is federated config. Now, I was showing a very trivial decK file as an example. Here is, well, I know you can't read it, but this is a decK file. This is about 20% of the decK file, and this isn't even a particularly big one. This is only about 800 lines with various plugins and routes and consumers and things configured. Having all of this in one file gets very difficult to manage. You could split it into multiple files and then apply them all together. But like I said, when you've got lots of consumers, that can take too much time. And honestly, in an ideal world, you don't want to be owning all of the configuration because what happens is someone comes along and says, I need a new service. Or they say, can you change this route? Or this plugin config is wrong. And they all come to you. And you end up just, I don't know what's going on. All these teams want changes. I'm a bottleneck. I'm the one that has to apply these to the control plane. What federated config allows you to do is have all of those teams independently manage their own configuration and apply them directly to the control plane. And you can segment those configurations using tags. So if I take a look here, what I'm going to do is just change the state of the control plane. And this time, instead of services and routes, what I'm doing is I'm setting up some consumer groups and some consumers. So I can see that Alice is in the silver group, Bob is in gold, Charlie's in bronze, Danny's in bronze, and Eve is in gold. And of course, there are services as well. What we want to do is start breaking this out into multiple files. So we might say consumer groups. Consumer groups are not owned by a specific team. I want those to be owned by the platform team. So what I'll do is just move those into their own file. Let's take a look at the services. We have bookings, customers, destinations, and flights. So let's create files for those. So the bookings team, the flights team, the customers team, and what was the final one? Flights, or destinations team. And then we start splitting these out. So no consumers. The destinations service. Actually, I'll do this. So that's the flight service, the destination service. I also need consumers, sorry, customers and bookings. So the booking service is split and no consumers. And then finally, the customers. And when we take a look at these individual files, you can be able to see just how much more manageable they are. And these can live independently in the platform team repositories, completely separate from the rest of your configuration. Now, just like before, if I try and sync any of these, I'll just run diff rather than sync to show what it looks like. But if I tried to say just sync the customers team, it's going to delete everything. And that's because decK by default selects absolutely everything in the config because we haven't told it which tags to look at specifically. I'm going to reset my control plane because we're going to build this up piece by piece. This select tags line is where the magic happens. So in your config, what you can say is everything in this is related to customers. Everything in here is related to consumer groups. Everything in here is related to bookings. There's everything. Oh, everything in here is related to destinations. And everything in here is related to flights. And now what happens when you try and sync any of these? So if I run diff for the customers team, it's going to just apply that customer service. And that makes sense because it's the only thing in the control plane. But now if I try and sync bookings team, normally we'd see that the customers team is removed. But this time it wasn't. This time bookings was created. And I can run decK gateway dump and see that the bookings and the customer services both exist. And we can see that they've actually got these tags that we defined in select tags. So what select tags does is it says only look at entities in the control plane that have this tag when calculating the diff. What this allows you to do is segment your configuration by team and then apply ports of the configuration. And so if I apply the rest, I just remove the full file and sync everything together. So what I just did there was a mistake. You cannot sync multiple files that use different tags at the same time. So you have to sync them one by one. So bookings, consumer groups, the customers team, destinations team, and flights. And now if I go back to the control plane, we'll see those four services exist and they all have the specific tags. This is how you can enable teams to all write to the same control plane without stamping on top of each other's configuration. Now there is one final thing I need to show you, and I deleted the full file, so I'm going to have to recreate this again, which is if I add a consumer called Alice, and no, I'll do it here. Let me remove that consumer. I should do all this declaratively rather than mixing and matching. And then consumer groups, name gold. Deck gateway sync consumer groups. Okay, I got the structure wrong. Must validate at least additional property consumer groups is not allowed. It's just called groups, I think. And this is where the live demo falls apart because I accidentally deleted the wrong file. Do I have it in here? No, I don't. What I was going to show you is there is a piece of functionality. In fact, I can do it without consumers. Let me show you with plugins. Um, Format version. Let me create a plugin. Imagine that I create a keyauth plugin. That's going to create a global keyauth plugin. And it has the tag plugins. Now imagine that we don't want that to be global and we want instead to attach it to the customer service. If I go in here and say attach it to the customer service, and we're going to get an error because it's going to say I couldn't find the customer service. And that's because the customer service has the tag customers, but the plugins have the tag plugins. So what you can do is actually tell decK, whilst you're looking up foreign key references like service, I also want you to look for everything with the tag customers. Uh, And now when it runs, it's created that plugin on the customer service and removed the global one. And it's applied to a service. So this is how you can have platform level things centralized, things like consumers, consumer groups, maybe even services, but then allow teams to have their own configurations that reference that config using default lookup tags. That part of the live demo was a bit rough, wasn't it? If only I hadn't deleted the full config. But hopefully you get the idea how you can allow teams to self-manage their config without trampling on top of each other, while still having a shared platform config for entities that everyone can reference. Now, that's a great start if you know what the services are called. So, for example, to add the keyauth plugin just then, I needed to know that I was adding it to the customer service. But what if the team changed the customer service name? What if they called it users rather than customers? Our pipeline would fail because we couldn't actually find the customer service that we're using as a foreign key. This is where API ops comes in. So API ops allows you to work with the config that is provided in a pipeline. It allows you to do things like iterate over every service and ensure that plugins have been set. So for example, if we had the flight service, this is the demo that I just showed. This is owned by the team. This is owned by the platform. You can layer on a keyauth plugin, so the team doesn't need to think about authentication or anything like that. You can just say, okay, the flight service has keyauth. But then when we add the customer service and the destination service, you have to go in and add another one of these plugins over and over. You just constantly be playing catch up. This is a diagram, or this is part of a diagram of what API ops enables. So you can have the actual application team, so the Flights API team doing all kinds of things, layering on plugins, generating from Open API, which we can show later. Then you have your platform team layering on linting rules and observability plugins and authorization. There's a lot of flexibility in these pipelines that you can use to build really powerful governance engines. Which takes us on to demo number 3, which is API ops. So if I just decK gateway sync full, let's just reset back to a state that we know. And here we have 3 APIs: bookings, flights, and actually this public API that Conga have decided to add. Now, this isn't great. All of these APIs are fully open to the world, and as a platform team, you want to layer on some authentication plugins. You could go to the team, say, I need you to update your config, or you can write a patch file. So this add plugins file says, okay, for every service in the config, I want you to add a key auth plugin. So what happens is you run decK file add plugins, pass in the state file that you're working with, and then your list of plugins. And you'll notice that every service now has a key auth plugin attached. You might be thinking, okay, well, that works, but I could just add a global plugin. You could, but actually this public API, it shouldn't have an authentication plugin. And what these selectors allow you to do is conditionally select specific services. So if I change this, we could say, okay, I want to select every service that is not called public. So now if we run it again, we can see that the booking service has authentication, the flight service has authentication, but the public one doesn't. And now you're starting to see just how powerful these pipelines can be by conditionally layering on things like plugins. Now imagine you're a platform team and you want to enforce some linting rules. So for this, root protocols must be present. There must be an array, and it must have one item, and that item must be HTTPS. So what we're saying here is, I'm just going to check. These routes do not have protocols defined. So if we lint this, decK file, we don't want to do the patch, just want to lint. It says root protocols must be present, protocols must be defined. So because we're not defining any protocols, it will use the defaults. What we need to do is go in and say, okay, this route has protocols and it's HTTPS. And let's add that to every route. And now when we rerun the linting, we'll see that it passes with no errors. And if we change this to HTTP, we can see that there is a linting violation. This allows you to enforce policy at CI time, so that your teams can write whatever they want in the declarative config files, but you can still enforce that platform level consistency. Now I'm going to take all of those protocol lines out again and show you how it fails. Like linting is the gentle nudge saying, okay, like you really need to be setting protocols and they need to be HTTPS only. But what if you just wanted to overwrite things centrally instead? That's where patch files come in. So you can use the deck file patch command and say, for every service, for every route, just set the protocol's value to HTTPS. Full. And you'll see that protocols has automatically been set on every single route. And you can pipe this into deck file lint to ensure that your patches have actually worked. So you can use a combination of forcefully overwriting along with linting to make sure that your governance is being applied as expected. So we've seen decK gateway apply, my latest favorite feature for incrementally building up your configuration. We've seen how to segment your configuration by team using select tags and default lookup tags. You've seen how to enforce and automate API governance with decK file lint, decK file patch, and decK file add plugins. But this isn't where it ends. There is some special bonus content around generating configuration because maybe your team don't know about Kong. Maybe that's just an implementation detail. Maybe your team is just working with OpenAPI. You know, they define the roots, the verbs, the query parameters and path parameters, things like that. And what if they wanted to go to from that to a Kong declarative config file? This is where decK file OpenAPI to Kong comes in. Let's do it that way. DecK file OpenAPI to Kong. And I've given it the wrong file. And I'm in the wrong directory. All right. So I take the OpenAPI file and I pipe it through OpenAPI to Kong, and it gives us this declarative config file with a service with multiple routes. And what I can do is just pipe that straight into decK file, decK gateway sync. And when I go back to the control plane, we can see that flight service exists and all of the routes from our OpenAPI file are there. So this is how your teams can work with Kong without necessarily even knowing about Kong. And this works really well with the API ops method because your application teams write OpenAPI specs, and then you use decK file add plugins or decK file patch to add additional information to the declarative config that is generated. But once you've got that declarative configuration, you can do so much more. So like instead of syncing it, what if we said decK file const kick? So what if you're not actually working with a decK file? What if you're working with HTTP routes because you're a Kubernetes shop? Sandeep, you asked about AKS and EKS. This is where it helps you. Because now you're getting Kubernetes resources. Look, there's a HTTP route pointing at the flight service, checking the flight's route, checking the flight number. Right, so you don't actually have to have your team write anything, whether that's declarative config, whether that's Kubernetes resources, that can help generate those. And if you're not a Kubernetes shop, but instead you're a Terraform shop, it can do the same. Here's a gateway route. Here's the gateway service. And to just show you what that looks like, I'm going to do a decK gateway dump, feed that to Conc2TF, and then I'm going to adopt all of those entities using Terraform. So what that just created was a file called main.tf. This is my control plane ID that I created earlier. I passed that on the command line. It's created a service, a route, but it also generated these import blocks. And what that allows me to do is run Terraform apply. It says it will import 5 things. Now I can start changing them. So this service is called the flight service. What I'm actually going to do is change its name to flight service demo and run Terraform apply. And when I go back to the browser and refresh, you see that's changed. So in literally 3 minutes, we went from an Open API spec to declarative config. We sent that up to connect as our control plane. We exported it again with decK gateway dump. And then we had Terraform adopt those entities and start managing them. decK is so much more than just, hey, I want to sync my config. It's a whole ecosystem for working with Kong's declarative config format and all of the supporting tools like Kick, like Terraform. That was the special bonus content, being able to generate configuration from other formats, both from OpenAPI to Kong and from Kong to Kick and to Terraform. That brings me to the end. Thank you very much for your attention, and I'm going to take a look at any questions that have been asked.
Amazing. Thank you, Michael. Let's see now. Will we have, I think we have a few questions in the Q&A already.
We do. Is there a backwards sync to create configuration YAML from already deployed routes? Yes. That is the decK gateway dump commands that I used at the end. So that will let you generate a YAML file from an existing control plane. Is it a good practice to keep, manage, or maintain consumers' related config data in YAML files? The answer is it very much depends on your business. If you're using consumers, the answer is yes, but they tend to be segmented away from application team configs. So something that's centrally managed from the platform team. decK also has the ability to read input values from the environment. So what people tend to do is have the consumer names and IDs in the config file, but passing credentials through the environment. So those are injected in the CI pipeline when it syncs. Resetting the whole config to recreate a new distributed and tag config can be dangerous. Is there a safe strategy to add tags and existing distributed config? Yes. You can go in and manually add the tags to all of the entities that should have that tag. There's 2 ways to do it actually. One is using the UI, so you go in and add the tag manually. The second is using decK gateway apply without specifying select tags. The 3 ways. The third is to take your existing declarative config file and manually add the tags entry. So instead of adding select tags at the top, you go through every entity and add tags specifically to the entity, then sync, and then start partitioning your entities up into multiple files using select tags. I did it from scratch for speed today, but there is a way to do it non-destructively. Does the decK dump command results have IDs for also? It can decK gateway dump normally. It does not specify IDs, which is the second half of your question. Like, how does decK sync decide to update a resource and not create a new one? Does the name have to be the same? The answer is yes. If you don't have IDs, decK will match on name. But if you want, you can use decK gateway dump dash dash with dash ID, and that will also export the IDs. And what that will enable is if you change the name, it won't delete and create an entity. It will update the entity with the same ID with the new name. There are trade-offs for both approaches, but we do support explicitly working with IDs and matching based on them. Any other questions?
I think we had one question in the chat, or did you already go over it?
Yes. What is the real use
Okay.
of decK whilst I'm using a managed AKS and EKS cluster? The point that I showed at the end, the decK file Kong to kick, that allows you to generate Kubernetes CODs from an Open API spec or from a Kong declarative config and apply those directly to your cluster.
Any other questions for Michael? We have some more time, so ask now is the time. In the meantime, I'll get the link for our YouTube channel where you will be able to find the recording.
Oh, hopefully I opened your eyes to what decK can do if you've just been using it for decK gateway sync. There are a lot of commands, a lot of opportunities. If you go to docs.conkhq.com/decK, that documentation has recently been revamped, really focused on real world use cases. So everything I showed you today is available in the docs with examples. So if you're interested, go and take a look. And if you've got any questions, please let us know.
And you will receive in the follow-up email, you will receive links to the decK doc site. I've included all of those. And you can join us on the Kong community Slack if you have any questions. Let me just put the link in as well here. All right, well, it doesn't look like there are any more questions. Michael, thank you so much for joining us again and for your presentation and the demos. And thanks everyone who joined us. I hope to see you next time again. And I wish you good evening, good day, and see you next time.
Thank you all.